eet114, Chapter 20, Power AC, Problem 20 is a power factor correction problem. The loading of a factory on the 1000 volt 60 Hz system includes 20 kilowatts of heating, unity power factor, which means purely resistive, 10 kilowatts P sub L, induction motors 0.7 lagging power factor, 5 kilowatts lighting 0.85 lagging power factor, which both mean inductive. Part A, establish a power triangle for the total loading on the supply. So you want to find S sub T, P sub T, Q sub T. So on load 1 that you're given, P equals 20,000 watts, Q equals 0 var. Load 2 is this load. The angle equals inverse cosine of 0.7 equals 45.573 degrees. So this is the angle here. X is what you're looking for, which is Q for this load. And then P was given as 10 kilowatts. So the inverse tangent of Q divided by P equals, you can find X that way, which is also Q. And it ends up being 10,202 vars inductive. And then for the last load, load number 3, again you do the same process. Theta equals the inverse cosine of 0.85 equals 31.788 degrees. So you write that in here. This is P. The inverse tangent of Q divided by P. This is the formula. You know what P is, and you know what the phase angle is, so you can figure out what Q is. That's 30.98.7 vars inductive. So P sub T equals 20,000 plus 10,000 plus 5,000, which is 35 kilowatts. Q sub T equals 0 plus 10,202 plus 3,098.7 vars for a total of 13,300.7 vars inductive. And then S sub T is the total apparent power equals the square root of these two guys squared added together equals 37.442 kVA. So here's the triangle. This is what it looks like from these three values. They figured out what the phase angle is 20.81 degrees. And you could figure that out by doing the trigonometry on this triangle here. So then part B says determine the power factor capacitor required to raise the power factor to unity. So basically you have to balance out the Q's. You figured out the Q total here was 13,300.7 vars inductive. So you want QC to equal that. So from that other formula that I showed you guys, this formula here, CV square, the power, and then inductive circuit or a capacitive circuit. Hold on, let me get back to here. X sub C equals V squared divided by Q. Q equals V squared divided by X sub C. So what you do is just flip the Q and the C around, or the Q and the X. You're given the E, it's a 1000 volt circuit. So E squared is 10 to the 6th. And then Q sub C, you're given that. That equals 75.184 ohms. And then you can figure out the capacitance from this formula that you guys know all about. It's a 60 hertz system. Plug in the reactance. You get 35.28 microfarads. And then part C, determine the change in supply current from the uncompensated to the compensated system. So uncompensated, the supply current source current is S sub t divided by E. We figured S sub t is 30.442 kVA divided by 1 kV equals 37.44 amps. In the compensated system, S sub t equals P sub t equals 35 kilowatts, which we were given here. So I sub S again equals S sub t divided by E equals 35 kilowatts equals only 35 amps. So the delta current, the current went down from 37.44 to 35, saving 2.44 amps. So you can see how over time that would add up and save money.